Question 12a. In the diagram, PR is a tangent to the circle with center O. That's this line PR. It's a tangent to this circle with center O. At Q, that's at this point, it meets the circle at this point Q. This thing says something about a line from the center of circle that hits a tangent makes a 90. That should be noticed first. Now, the question says angle POQ is 56 degrees. This is 56 degrees at O to P and to Q. And PO intersects SQ at V such that angle SVP equals 109 degrees. Now, this angle is 109 degrees. That's this line crosses this line, and this angle is 109. This is 109, this is also 109. If you're very good with vertically opposite angles, if this is 109, this angle here too is 109. Now, calculate angle for the first question, TQP. It's at Q to T to P. That's at Q to T to P. That's this angle for the first question. Second question, calculate angle QTS. That's at T to Q to S. That's this whole angle here. We know the first question says calculate angle TQP. That's this angle at Q. Let's zoom in to get a better view. And we're asked to calculate this angle here. And to solve this question is very easy if you understand what to do. Circle geometry is not really hard. I describe it as a form of hide and seek math topic where you're given something and you're asked to find another, and you have to use the theorems to find what you're looking for. Now, we know if this is 56, normally this should be 56 divided by 2, that's 28, and this is also 28. You might wonder why. Now, you've been asked to find this angle here. This is a tangent here, and this is a chord here. Now, what should come into your mind first is all theorems as related to tangents. The first one was a line from the center of the circle that hits the tangent is 90 degrees. That's one of them. There are two others at least. And there's this particular one that talks about the angle formed between a chord and a tangent is the same as the angle the two ends of the chord forms on the circumference of a circle. That's this. And it has also been discovered that when you have that same chord, the angle the tangent makes with that chord, let's say the angle the tangent makes with the chord, is actually half of the angle the two ends of the chord make with the center of the circle. So if this is 56, this should be 56 divided by 2. Although there's no direct theorem as regards it, the one that really works is alternate segment theorem. Solving this question this way makes it look easy, like it seems as if it's easy to figure out, but it's not actually easy. Imagine this 109 is not useful in answering the first question. The purpose of this page is not just for you to get the solution, but to understand how to solve questions like this. Circle geometry questions can be really tricky, but first you have to do is understand all the theorems under circle geometry and know which one to apply in which case. And like in this question, we're given the one that has to do with a tangent and a chord, and the best fit to that is alternate segment theorem, that says that the angle the chord forms with the tangent is the same as the angle two ends of the chord forms on the circumference of the circle. And when you have this, you also have this. So this 56 is what we need to solve the first question. So let's follow the normal process. To solve this question, first we use this 56 to find this angle here. That angle TSQ with S in the middle. So we have this angle. We're looking for this angle here first, because it's the angle that will help us get this angle, because they are the same. So we know to get angle TSQ, we know it's related to this. That the theorem that helps us solve the question is angle formed at the center of the circle is twice angle formed at the circumference of the circle, from the fact that the two angles are formed from the two ends of a chord. That's this chord, this particular chord here. Now we'll go on and take it as angle TSQ is angle TOQ over 2. That this angle is this angle divided by 2. And the theorem that guides it says angle formed at the center of a circle is twice angle formed on the circumference of a circle. So we have angle TSQ as 56/2. That's 56 divided by 2, which gives us 28 degrees. That means angle TSQ is 28 degrees. Now we know this angle is 28 degrees, so we can indicate it. And we know this angle here is the same as this angle here, because the angle between a chord and the tangent to a circle is the same as the angle the chord makes on the circumference of the circle on the other side, not on this minor segment in this case, the major segment in this case, that it makes on the opposite side, not here on this side. Anywhere you have an angle from the ends of this chord here is also 28 degrees. We have to note that. We're referring to this theorem, that's alternate segment theorem on tangent in circle geometry, where the angle the tangent mixed with the chord is the same as the angle the two ends of the chord makes on the major segment or on the circumference of the circle on the other side, not on its side, not on the side where you have the angle between the tangent and the chord. It's on the other side. So we should note that too. And it should also be noted that there should be a theorem that has to do with similar thing that as regards the tangent and the chord. The angle the tangent and the chord mix is half of the angle the ends of the chord mix at the center of the circle. It's always true, because the angle the ends of the chord mix with the center is twice that it makes on the segment, which is the one on segment is the same as the one made between the chord and the tangent. So that should also be noted, because if this is 56, this is going to be 28. That's 56 divided by 2. It's always true. It's just same as this angle here is same as this. Well, this has been proven to be angle formed at the center, which is this, is twice formed at the circumference of the circle, and the one formed at the circumference of the circle by the two ends of the chord is the same as the one the chord makes with the tangent, which is this angle here. But for working sake, we now know that angle TQP is same as angle TSQ. That's this angle that we're asked to find, that's angle TQP, that's at Q, which is the one in the center here, is the same, equals angle TSQ as TSQ. They are the same. This angle here is same as this angle here, and you have to write the proof, and the proof is alternate segment. You can write in circle geometry. Therefore, angle TQP is 28 degrees. That's the answer to the first question, is 28 degrees. We now know this angle is also 28 degrees. Question 12 AII says, find angle QTS. We've been asked to find this angle QTS, that's this big angle here. And there are actually several ways to find this angle, depending on what you see first. Like been said in previous videos, there are several ways to solve a math question depending on what you see, provided it's guided by laws in math. Now, looking at this, we can get this by several ways. The path we will follow in solving this question is using this 109 to get this angle here. Once we have this angle here, this is now a triangle, VOQ. Once we have two angles in a triangle, we can get the third one. Once we get this third one here, then we use this 90 degrees here, because angle from center of the circle that hits the tangent makes it 90 degrees. So we know this is 90 and this other half is 90. So if this is 90 and we have this angle and we have this angle too, we can do the addition of these two angles. Minus 90 will give us the inner angle here. And once we have this angle and we have this angle, we can therefore get this big angle, taking into consideration this triangle STQ. That in circle geometry, you have to be capable of seeing shapes in shapes, because now that we have this angle and we know this angle, we can therefore find this angle, taking into consideration, and if you're able to spot out this triangle here, that's triangle STQ, then you solve for T. Now we know this angle here is 109, then this other angle on this other side here is also 109. That's vertically opposite angles. That we know angle OVQ is 109 degrees. That's vertically opposite angles. That's this angle here is 109, so we can just mark that out as 109. Now this angle here is 109. Now taking into consideration triangle VOQ, we have two sides. We have one with 109, we have 56 degrees. We can find this angle here, which is angle OQV. Taking into consideration this triangle VOQ, that's this small triangle, and we now have that this is 56. We know this is 56 degrees. This is 109 degrees. We can find this angle. Let's say this angle here is x. So we'll solve for x. Taking into consideration this triangle VOQ, we'll solve for x. So we know x plus 56 degrees plus 109 should equal 180. Our sum of angles in the triangle. So we have that 56 plus 109 plus x equals 180 degrees. Our sum of angles in the triangle. So we do 56 plus 109 is 165 plus x equals 180 degrees. X equals 180 minus 165 plus 165 crosses equals sign and turns to minus 165. X equals 180 minus 165 is 15 degrees. Now we have our x to be 15 degrees. We have this angle to be 15 degrees. And remember, the angle formed from a line, that's the radius, from the center of the circle that hits the tangent is 90. That means this total angle here is 90. That's taking into consideration the angle PQO is 90 degrees, and we have two of the three angles that form the 90. That means the addition of these two minus 90 degrees will give us this angle here. That's angle TQV, this angle here. So we can solve for it. We know, let's say this angle we're looking for here, that angle TQS, let's say is y. We have this angle to be y. We know this angle here, which we just solved for, is 15 degrees. And we know this is 28 degrees. We know this total angle from here to here is 90 degrees. So with that, we can find angle y. That's 28 plus 15 plus y equals 90 degrees. And we can then solve for y. So we know this is 90 degrees already. We're taking our angle TQS to be y. So we have it as y plus 28 plus 15 equals 90. We know why the sum of all these three angles equals 90, because a line from the center of the circle that hits the tangent makes a 90 degrees with the tangent. Y plus 28 plus 15 will give you 43 equals 90. Y equals 90 minus 43 degrees plus 43 crosses the equals to sign and turns to minus 43. We have our y to be 47 degrees. That's 90 minus 43 will give you 47 degrees. Now we have this our y to be 47 degrees. We can change it to 47 degrees. And with this 47 and this 28, taking into consideration this big triangle here, STQ, we can get the angle we've been asked to find. We can name the angle, which is QTS, we can name it Z. And knowing that the sum of angles in the triangle is 180, that's Z plus 47 plus 28 equals 180. Then we'll solve for Z. We know angle QTS is Z. Then taking into consideration the big triangle STQ, we'll find the angle which we've been asked to find for the second question. We now know Z plus 28 plus 47 equals 180 degrees. That's sum of angles in a triangle. So we know Z plus 28 plus 47 is 75 equals 180. Z is 180 minus 75. That's plus 75 crosses the equal sign and turns to minus 75. We have our Z or our Z to be 105 degrees. That's the answer to the second question. A quick recap of what we did is that we are given this as 56 degrees and this as 109 degrees. And with the 109, we found this angle here, which is vertically opposite to the 109. And with that, we took into consideration this small triangle here, and found this angle. Since we have two angles in the triangle, we can easily find the third one using sum of angles in a triangle equals 180. Once we have that and we knew this was already 28 degrees, we found this as 28 degrees. We could find this as 47 because we have two angles of the three angles, and we know the total sum of these angles is 90 degrees. Angle formed by the line from the center of the circle that hits the tangent is 90 degrees. We got this to be 47 degrees, and we already know this is 28 degrees. And with this 28 degrees and this 47 degrees, we found this angle here, the angle we've been told to find, by saying the sum of angles in the triangle is 180, because we have two angles in the triangle and we're looking for the third angle. And taking into consideration the triangle TSQ, this triangle here, we found the angle we've been asked to find. As said earlier, there are several other ways to find this angle we've been told to find. Now, another approach that you can use is taking into consideration this triangle. You can find this angle first, then you find this angle second, this angle B. Find angle A first, then angle B. Then you add them together to get the total angle you've been told to find. Depending on how you see the question, circle geometry sometimes are not a one-way thing. There are several ways to get to your answer. So let's say we take this triangle here. We have this as 28 degrees. We have this as 109. With this 28 and 109, we can get this third angle. That sum of angles in a triangle is 180. That's 28 plus 109 minus 180. 28 plus 109 is 137. Minus 180 will give us 43. That's 180 minus 137 will give us 43 degrees. That means this angle A here is 43 degrees. And to get angle B, you can take into consideration this triangle also. The line from the center to hit the circumference is the radius. Same as this from here to here is also hitting the radius. That means this is probably an isosceles triangle. At least two lines are established to be equal. This line and this line is equal. That means if this is B, this is also B. So we can say B plus 56 should equal 180. Then 180 minus 56 is 124. Since both angles are equal, we can say 124 divided by 2, since they are equal, will give us 62. That means this angle is 62 degrees. Now, if we add these two angles together, 62 plus 43 degrees, to get this angle, that's 62 plus 43 degrees, will give you 105 degrees. So using this other method, you can also get your answer to be 105 degrees. You might not have noticed that this is an isosceles triangle, as these two lines are equal. Now, you might have seen this as 90 degrees, that this total angle is 90. And once you have that this is 90 and this is 56, and this is a triangle, POQ is a triangle. With this 56 and this 90, we can get this angle as sum of angles in a triangle, as 90 plus 56 minus 180, which will give you this angle as 34 degrees. Now that you have this angle as 34 degrees, with this 34 and this 28 degrees, you can find this angle here. It's like, this is also a triangle. This is PTQ is also a triangle. So we have two angles in the triangle, that's 34 and 28. We can find the third one, that's the addition of these two minus 180. When we add these two together, you get 62. 62 minus 180 will give you this angle, and this angle is 118 degrees. And with this angle as 118 degrees, we can therefore put into consideration this straight line here that goes like this. You can see it like this. This is a straight line. You've traveled 118 degrees. So angle B is 180 minus 118. That's angle on the straight line. And 180 minus 118 will give you 62. Then the 62, which is the angle for B, plus 43 degrees, will still give you 105 degrees. This is just to show you that there are several ways in solving some questions in circle geometry. Depending on how you see it or from which angle you see it, you still get your answer.